Okay, question 10. We've got electromagnetic induction here. So we can see we've got a coil of wire. I'll write cow. Here is a magnet, north and south. Might be the other way around. And it says, explain what will be observed when the magnet is pushed in and out of the coil repeatedly. So we're going to see the dial go that way, and then when we push it in, and then the dial will go that way. So it will flip from positive to negative, or the other way around, because I don't know what the poles are on that. So turn that into words. So the needle will oscillate or vibrate from positive to negative, or negative to positive, because the coil experiences a changing magnetic field. So we know we've got our butterfly. So when this goes into the coil here, this will experience a strong field when that pole's first in. As we get into the middle, it's going to be a weaker field. But that is that key thing. So I'm just going to write CMF there. And the change in magnetic field cuts the coil, inducing an alternating current. And there you go. That's a pretty key thing. Again, I even danced in front of you in the class in terms of embarrass myself with all the silly things to make you learn it. Next part, we've got a transformer question. So we can see it gives us all the information. You know how to do these calculations, and it's assumed it's 100% efficient, which is rather nice. So the different ways. The one is we arrange it, and if you're good at rearranging it, but just be really careful that you're going to be left with 1 over the current in the primary. Or the other way that lots of you prefer is we look at it to see what type. So I'm not going to spend long on that. You can pause the video and watch that. But now we're just going to see that we've got, this is the primary voltage, so this is the input. So this is the alternating current in, use a capital C ray side. And we can see that this is a step down transformer. Okay, if it's a step down transformer, and we can see these things here, we're going to have to work out the current in the primary. And we can see the current in the secondary is this. So I'm not even interested in that. So we know that what do? Get the ratio for the two, for the coil. We know that if it's a step down transformer, voltage goes down and current goes up. So if the current has gone up here, it must be lower over here. And there we go. So it's get your ratio, 700 to 400, and then make sure that the input is lower, because the current will, so you know, it's that thing of don't mix up voltage. Now, personally, I'd stick to that, but I know a lot of you like this. So we've got that, we've got 1.7 to 1. We know it's a step down transformer, so voltage goes down, current will go up. If this current has gone up, it must have been lower to start with. There we go. So 1.75 over 1.75 equals 1 amp. Next question, lovely 6 marker to finish. We've got the national grid. So I'm just going to slowly go through all of those things. So power station, step up transformer, national grid, pylons and cables, step down transformer, mains, 230 volts, 50 hertz. So explain the stages from P to T. Your answer should include details of the effect that Q, R and S have. Q, R and S have on efficiency. So we're going to link efficiency in. So the first part, Q is a step up transformer. It increases voltage and decreases current. Lovely, nice and easy. There's a smaller current in the national grid to reduce cable heating, and this increases the efficiency of energy transfer. We also want a high voltage because we've got to push it over a large resistance. So a high voltage required due to the high resistance in the fact that these are ridiculously long cables. Next part. R is the national grid, which transfers low current between the power station and the homes. That's all we need to say. You could add in there it's a system of pylons and cables if you wish. Next part. S is a step-down transformer, which increases the current and decreases the voltage to 230 volts at 50 hertz for main electricity in the home. Transformers are not 100% efficient, as there is some heating. And there we go, and that's why they're not 100% efficient. I think that's a lovely way to finish the paper.